record to this computer. And here we good morning, Gabby or Courtney. It's so good to see you. It's so nice to see your beautiful face. Let's open up our slideshow for today. Hey, Annie, question. Is your icon, is that a picture of you? Because I feel like it's definitely I feel like it's just like a different angle, so I can't really tell. What do you think?
Yeah, it is. It looks kind of weird because of like the cropping and stuff, but.
No, like what I'm telling you is like that looks like a professional picture.
Oh, I took it myself.
Well, I'm very impressed. So keep up the amazing work, Annie.
Thank you.
I was like, dang, what actress is that? I don't know what I was thinking. Like I have somebody in my brain, but I can't remember her name. That I'm like, that's definitely that. Like, but no, it's Annie. Okay, I'm going to start to share my screen, and we are going to start off on our warm-up for today. Well, I went the wrong direction. We're on slide number 2, and we're looking at that solving equations piece. I don't think I clicked the right screen. Let me try again. Boom. Okay. So I'm pulling up my participants. I'm pulling up my chit chat. You are taking, I'm going to give you 2 minutes to look at this equation, do some work with it, and decide what kind of solution it's going to have. There are 3 types of solutions that it could have. I want you to take 2 minutes right now to get started. Why didn't I mark Kaylee B? She's here. Carter Mario is not here. Leah is not here. Diego is not here. What? Where is everybody? Jonah. Faith is here. Faith P. Faith P. Carter Mario is here. Or maybe it's Christmas Carter. I don't know. Good morning, Faith P. and Carter Mario. That's like the lawyer. I still like Christmas Carter better. Okay, we're taking another minute to decide how many solutions. Yes. Exactly, Jaden Ramos. How many solutions is it going to have? I'm going to come over here. I'm going to write some stuff. Infinitely many solutions or no solutions? Okay, here we go. Let's come back together. Okay, I have a lot of questions for you. First thing I want to ask you is when I'm looking at, let me just find my mouse. Oh, Shelby's back. Why is Shelby back? Let's see. Hey, Shelby. So Shelby, you should definitely be in science right now. Just an FYI. Okay, Shelby? Hop over to science. I'll see you tomorrow. Bye, Shelby. Okay, so there are 2 first moves that we can do with this equation here. So when you looked at this one here, what was your sort of gut instinct for the first move? What were you thinking to do first? Because there's 2. Jaden Ramos said his first gut instinct was to distribute. I agree. That is a very good first move. Is there another first move that we could do with this though? That like makes it, I don't like fractions. I am fraction intolerant. Very good, Jaden Ramos and Bridget. We can multiply by the reciprocal or the flip of that. I don't know why that's flip. It's like the flip of that fraction. Very good. So if I want to get rid of this 1/4 here, I can multiply by what number? Very good, Jaden Ramos. Very good, Bridget. 4/1. If I multiply by 4/1 over here on the left, it cancels out. I'm left with this 20D plus 4. Let me see who else is trying to join us. Diego is here. Fantastic. And then what am I going to have to do to my right side of the equation? If I multiply the left by 4/1, what am I going to do to my right?
Multiply by 4/1.
Yes, nice job, Alyssa Button. Multiply by 4/1 as well. Let me grab my red because I like red. Multiply by 4/1. And if we remember, this 5/1 means the same thing as 5D/1 as well. Good, no problem, Diego. No problem. So I have to multiply here. When I multiply 5D times 4, or just 5 times 4 is, you didn't miss much, Diego. Very good. 5 times 4, awesome job, Jaden Ramos, Olivia, and Diego. Thank you for that. Is equal to 20D, right? Over 1. So we can say that 20D plus 4 is equal to 20D, right? And I'm looking at this 20D here. Oh no. And there's no constant. If there's no constant, it's like saying 20D plus how much? If there's no constant written there, it's like saying 20D plus. Very good, Jaden Ramos, Bridget, Olivia. Yes, it's like adding 0. So we have this equation here now. What do we notice about both sides of this equation? Very good. On both sides, Olivia Webster and Jaden Ramos, they said we have a 20D. So when we have the same variable or letter on each side, then we know it's either going to be infinitely many solutions or no solutions. To decide which it's going to be, we then need to look at our constant, because infinitely many solutions have the same constant. No solutions have different constants. So what do we notice when we look at our constants here? Are they the same or different? Very good, Jaden Ramos. Very good.
Does that say 20D plus 4 equals 20D?
20D plus 4, 20D plus 0. Because remember, if there's no constant there, it's like saying 20D plus 0. Because I just wanted to, nice job, Bridget. I just wanted to put a constant so that we can make that distinction. So if we look at these constants, like Jaden said, they are different, right? We have a 4 and we have a 0. So if we have the same variable, but different constants, what kind of solution is this going to have? Nice job, Bridget. Same variable, different constants, it's going to have, well, no, Billy, we don't want to take it that next step, because if we take it that next step, we would minus 20D minus 20D, it would cancel, we would have 4 is equal to 0. Right? That's what we'd be left with. So when we But when we look at it, Billy, at this stage right here, we have the same variables. We don't need to take it any further because we know it's going to have no solutions because it has the same variable, different constants. So it's going to have no solution. Boop. I'm going to leave that up for you to copy your, does that make sense though, Billy? So you could take it that next step of subtracting your 20D, but when you subtract 20D, you're not left with any Ds because you have 20 Ds and then you take them all away. So you have 0 Ds. I love when we use the letter D. So then we'd be left with 4 is equal to 0, and then that would mean no solutions. When you have two numbers that are different from one another, equal at the end, if you have no more variables left and just two numbers equal to each other, then that's going to be no solution. Okay? No solution for this one. I will give you a moment to write it down, and then I'm going to move forward, onward and upward into the valley of death. I don't know. Okay? Wonderful, wonderful, wonderful. I am going to move forward. I'm going to erase, and we're going to look at the next piece of this, okay? So our learning targets for today, we have one learning target, same as it was the other day. We have this idea of determining whether an equation has no solutions. We also say as that NS, no solutions. One solution, which we're really going to talk more about today in the afternoon work. And then this idea of infinitely many solutions, IMS, okay? And we're going to look at those definitions of what both of those mean, okay? So if we think about this concept, this idea of infinitely many solutions, we're going to say to ourselves, let me just close this out. Give me a second. We look at slide number 4. Once again, we have these definitions and examples of no solutions versus infinitely many solutions. So if we look at this concept of no solutions on the left-hand side of this box here, this idea is that there are no values that you can plug into this equation that will make it true. So even if you plug 1 in on both sides, it's never, ever, ever going to be true. If we look at what it looks like graphically, we're going to say, or equationally, I mean, really, in an equation, what's that's going to look like is it has the same x values or variables. Okay. The variables are the same, but the constants are different. So an example that we had here was 5x plus 4 is equal to 6 plus 5x. Another example where we have the same variable of 7x plus 9 is going to be equal to, once again, 7x, but my constant needs to be different. So any number other than 9, I'm going to say plus 70. Boom. That's my example. I want you to take 30 seconds right now to write your own example in the chat of an equation that would have no solutions. I'm going to write some of them up here. So I want to see everybody take 30 seconds right now to write their own equation that would have no solutions using my 2 examples. Nice job. I'm going to start to write some of them. I'm going to write them just as I see them, and we're going to talk about them. Nice job, Bridget, Jaden Ramos, and Sawyer. I want to see a couple more friends give me some examples. Plus -4 equals 7x plus 12. Good. And then let me just write down one more that we got from Melissa Button, which was 9x plus 3 is equal to 9x. I think you put the x in the wrong spot, plus 6. Nice, nice job. Very, very, very good, Alyssa Button, Sawyer, Jaden, and Bridget. Thank you so much for being brave and giving me some examples. Good. Let's look at this first. Oh, go ahead.
The only reason I put it in the wrong spot was because I looked at your first example and it said 6 plus 5x, so I thought it'd be like the x would be like next to that.
Oh, so you want to write it like, you're saying you want to write it like this, like 9x plus 3 is equal to 6 plus 9x. Was that what you were trying to say?
Yeah.
Perfect. Nice job. And both of those are correct. And I like it. So let's look at Bridget's here. So if you look at Bridget's, we have the same variable on each side. We have a 2x. And when we look at our constants, they are in fact different. Nice job, Bridget. Fantastic. Woo-hoo. Now, if we look at Jaden Ramos's, he had a 9x. He had a 9x. Good job there. Now, if we look at our constants, we have a positive 4 and a positive 11. Nice job. Oh, give me 1 second on that, Diego, okay? I will answer that. Then if we look at Sawyer's. Yeah, give me 1 second on that, Diego, once I get to the end of this section here, okay? So we have the same variable here. Nice job. Different constants. Awesome job, Sawyer. And then I like how Alyssa Button said, hey, I liked the order, right? So she said she put her x's, she sort of tail ended each of the things here and then put our constants in the middle. Very good. And remembering that the order doesn't matter. It doesn't have to be x first, constant second. It can be constant first, x second, as long as the signs are the same, right? Very good. Nice job. Those are some really good examples. Now what I want you to do is I want you to take 30 seconds right now. Oh, Jaden, or Diego, it should still be in your drive though, shouldn't it? Just go back into your Google Drive. I want you to take 1 minute right now. I'm not talking to you, sorry, Jaden, I meant Diego. Take 1 minute right now to write an equation that would have infinitely many solutions, okay? Nice job, Bridget. Okay, so Diego, please make sure that you make your own copy of this before you make any typing in it. Okay, Diego?
Okay, is it called Germain Pathways Unit
Or
lesson 7?
Lesson 7, day 2.
Okay, thank you.
Do you want me to send it back to you? There, I just sent it to you. You can make a copy for yourself. Yes, very good, Alyssa Button. Oh, perfect. Lily was able to get in, but thank you, Annie, for that. I appreciate that. She was able to get in for at least a little bit, so I will mark her. Oh, she's still here. Good. Nice job, Lily. Thank you for being a trooper and getting in on if you could. Very good. Nice job. Fantastic. So now we're talking about this other idea of infinitely many solutions. So that's not a problem. Thank you for sending me that email, Lily. That was a rock star move. So if we're looking at this idea of infinitely many solutions now, any number that you plug into the equation will make it true. The x values or the variables are the same and the constants are the same. I gave us an example down here. Let's see some of these examples that people gave us as well. Bridget said 3x plus 6 is equal to 3x plus 6. Nice job. My 6 doesn't look that good, but that's okay. Jaden gave us one of 8x. 8x plus 6 is equal to 8x plus 6. Very good. We have the same variable, same constant on each side. Nice job. Alyssa Button said 3x plus 5 is equal to 5 plus 3x. And I love that you did that one, Alyssa, because we changed the order of these things, but they still are equivalent to one another. Very good. Very good. Now, let's look at Kaylee B's. Kaylee B said 10x plus 5 is equal to 10x plus 5. Yes, Kaylee B. It is identical on either side. Very good, Alyssa Button. Very good, Sawyer Fortin. Very good, Kaylee B, Bridget, Alyssa, Jaden. I know I said some names twice, but I'm so proud of you guys. Awesome. Very good. Infinitely many solutions. They are identical on each side. No solutions, same variable, different constant. Okay? Very good. Nice job. Let me clear my ink and let's take a look at the next slide together. No, not. Okay, perfect. Let's take a look at the next piece of this. Okay, actually, before I get started, I want to say one thing first. Your name, the name on the classroom now has at the end of it, it says path. That's not for you, that's for Miss Canton. She is going to be, we're going to be doing assessments through like a different, not through Google Forms anymore, it's going to be through a website. And so for her to easily put things into, for her to easily put assessments to our class, she needed me to indicate whether it was pathways or if it was algebra. So that was why it says path now. Diego, make sure you make a copy before you make any edits to this, please.
Yeah, I just saw your name, so I'm like, hold on, I gotta make a copy of this.
Perfect. You're a rock star. Now, let's take a look at slide number 5. Okay, so for these 3 equations, we need to, so path or pathways, it means, so like path is just like abbreviated pathways. So you might see it somewhere as pathways, you might see it like in the, if you look at the title of our PowerPoints, it says pathways, that means the same thing as path. And that's really more just for me and for Miss Canton so that we know which one. Oh, yours says pathways? Okay, not a big deal. Maybe it says pathways, maybe it says path. That means the same thing. Okay. Wonderful. Let's take a look at slide number 5 now. So slide number 5, Lily is joining. She is trying her best. It says complete each equation so that it is true for all values of k. So if it's true for all values of x, that means it has infinitely many solutions. That's what we can say if it says if it's true for all values, that means it has infinitely many solutions. Okay, so we need to do some work with all 3 of these equations so that they have infinitely many solutions at the end of it. So if we look at letter A, we have on the left-hand side, 3x plus 6 is equal to, oh no, and then we see like a 3 outside of a parentheses. Nice job, Jaden Ramos. What does that mean we're gonna have to do with that 3?
Wouldn't you do like distributive property to get the 3x together?
Yes, you would multiply or do the distributive property. Yes, Kaylee B. Yes, Alyssa Button. Yes, Jaden Ramos. I would multiply by that 3 by both of these pieces here. Okay, so when we distribute this, we're going to have how many k's?
Infinitely many k's?
Well, we don't know yet. Well, let's see. So when we do the distribution, 3 times x, we're going to get how many x's?
3 x's.
Yes, we're going to get 3 x's. Nice job, Jaden Ramos and Diego on that one. We're going to get 3x. And then we're going to have to multiply 3 times some number, but it has to be equal to what number if we want it to be infinitely many solutions? It has to be, when we multiply these, it has to be equal to this 6 because infinitely many solutions means it has the same constant on each side. So 3 times what number is going to get me to be that plus 6? Very good, Jaden Ramos, Diego, Olivia. Awesome, awesome job. 3 times what number is going to get me that 6? Very good, Jaden Ramos, very good. It's going to be a 2. So inside this box here, you would have to put the number 2 because it needs to be equal to a plus 6. 3 times 2 gets me a 6. Awesome job. Yes. Very good, Kaylee B. Exactly. I love how you put your thinking in the chat. That was so good, Kaylee B. Yes. You guys are so fantastic. It's scary sometimes. Oof. Okay. So we just did letter A. I am so proud of you guys. Now, letter B, I think, is probably the most challenging of the 3. So, my first question to you, we know that the left side is going to be equal to x minus 2, right? So that we're going to have to get the other side to be equal to look exactly the same as x minus 2. So, if I have this negative sign here, that's like distributing what number? A negative what? Nice job, Jaden Ramos. So if I have this negative sign here and there's no number, what number is like implied that it's there even though it's not written? We know it's there. Very good, Jaden Ramos. It's going to be like saying a negative 1. So we need to distribute a negative 1 to each one of these pieces here. And we don't know what this piece is yet. So negative 1 times what is going to get us a negative 2? Negative 1 times what number is going to get us a negative 2 at the end of it? What do we think? Negative 1 times what number is going to get me a negative 2 at the end? Nice job, Bridget. Nice job, Jaden Ramos. Very good. If we were to, for example, we need to be a negative number at the end, and we already have a negative. So it's going to have to be a negative times a positive, right? So this is going to have to be a positive here. And 1 times what gets me 2? 1 times what gets me 2? 1 times. Very good. Yes, Alyssa Button. Yes, Jaden Ramos. Go ahead, Diego. 2. Yes. So this one is going to have to be a positive 2 up here because it has to be a negative times a positive to get me this negative. And then a negative 1 times a negative x gets me what? Remember, a negative times a negative. Don't get confused. Very good. Negative 1 times a negative x is going to get me a positive x because 1 negative times a negative gets me a positive. Very good. Now, last one we want to look at here. We have what do we notice about this C here that's different than the other ones? What do we have? Very good, Gina Ramos. We have a fraction, and we can rewrite this fraction. We can break it into 2 separate pieces. We can rewrite it as 15x divided by 5 minus 10 divided by 5. We can rewrite it that way. We can break it into 2 separate pieces, and it's going to be equal to something minus 2. So when I do some division here, and I do 15 divided by 5, I get what? 15 divided by 5. 15 divided by 5 gets me. Nice job, Bridget. Very good, Jaden Ramos. It's going to get me the number 3. And because the 15 has an X and this one doesn't have an X, the X is going to have to come down because it doesn't cancel out. Good job, Jaden Ramos. Good correction there. And now so it's going to be minus 10 divided by 5 gets me what? 10 divided by 5 is, what do we think? Very good, Olivia Webster. It's going to get me a 2 because 10 divided by 5, nice job, Bridget, is going to get me a 2. And it's going to bring down this minus because it's a negative. Very good. Is equal to some number or something minus 2. If we wanted to have infinitely many solutions here, what is going to have to go in that box? If it has to have the same constants and the same variables, what's going to go in that box? Nice job, Jaden Ramos. Very good, Bridget. If we want this at the end to be infinitely many solutions,
5?
well, we know our constants are the same. So then what's going to have to go in that box that's on the other side?
Interesting question.
So let me phrase it a different way. How about this? So my constants are the same. Now I need my variables to be the same because if it's infinitely many, our variables are the same. So what's the variable going to have to be on the right side?
X.
How many?
3.
3, because the left side has a 3x. The right side is also going to have a 3x if you know that it's going to be infinitely many solutions. Okay, so awesome job on that. We're going to do the second piece of this activity tomorrow as a warm-up. So we're not going to do it now. You don't need to do it today. Where your afternoon work is going to start today. Let me show you. Where your afternoon work is going to start today. Let me try this again. Charmaine just needs to unclick one thing. Afternoon work is going to start on slide number 10. Okay, so today you have a Loom video. It's not Edpuzzle, so you can skip forward a little bit if you would like throughout the video. You're working on, for slide number 10, you're looking at and completing 11 through 15, right? So on 11, you're going to be writing a missing piece here that would give you no solutions, infinitely many solutions, and 1 solution. I'm going to talk about it in the video, so make sure. Oh, answer for C was a 3x, Alyssa Button. Okay, so you're going to find out no solution. What's going to go in here for no solutions, all solutions, just 1 solution. That is in the video. I go through a good explanation on that. And then you are solving here on these 4 equations. Once again, you can skip forward.